Hello everyone, welcome back here with this vintage shoebox tape recorder. It's an ITT SL54 Automatic. Now I don't know why people call this a shoebox tape recorder, because if I would have a box of this size, I can tell you my shoes would definitely not fit in there. So I don't understand. But anyway, in the last video I did the mechanical restoration, all the mechanics, and that should be done. And in this video we'll do the electronics. So yeah, these are all the electronics that I disconnected in the last video, and I already cleaned up the case a bit. I am going to take out the door here, so to get a bit more better access underneath, because it's also still quite a bit dirty over there. I believe it is not that difficult to remove. The only thing I need to do probably is remove this spring. On that side the spring is glued in. Let me move a bit to the side here. But if you remove this spring on this side, that should work. But it's quite a forceful spring, so yeah. See, the door comes out, but the problem is that the spring is glued in on that side. Yeah, okay, it was just as easy as unhooking it over there. And then push here on this side and on that side, and now the door should come out. Okay. Yeah, see, so it's still quite a bit dirty in there. Now I can clean that up much better. I already did clean the inside here a bit more. But let's have a look what we got here in terms of electronics. Okay, so I got here, this is the microphone, obviously the speaker. I'm also going to remove the speaker because I think it will also benefit from some cleaning underneath the speaker. Here on this side we have the transformer. This is the AC socket and the DIN socket for the input-output. This is the volume control. Here, this is the battery compartment. And then we have a number of things. Well, this is the motor, obviously. We have 3 PCBs, a big one and 2 small ones. I believe this is the microphone PCB, because you see this gray cable here, which comes from the microphone, is attached here to this PCB. There are a couple of capacitors on there. Yeah, indeed. Then this PCB here contains the filter capacitors and the bridge rectifier for if you are using AC mains. And then this is the main amplifier PCB, and then we have 2 switches over here. Now the first thing I'm going to do is clean all these switches, because we have in total 1, 2, 3, 4, 5 switches. This is the motor switch. So that one enables the power to the motor, and also selects in which direction the motor should turn. See, so in this position there is it's not making any connection, but if it goes to the left or to the right, well, that determines in which direction the motor should turn. Now you can see it is very tarnished, so it still works. Well, when we tested it in the last video it still worked, but I'm gonna clean it up anyway. This switch over here, this is a leaf switch as well, but it's a simple one. That cuts off, that enables the power to the amplifier PCB, and that is only activated when you press play. So that means that when you have the tape recorder in fast forward or in rewind, then the amplifier, the power is cut completely from the amplifier. You're only powering the motor directly to this switch. Only in play, when you push the play button, then this switch closes and you get power to the PCB. On the PCB itself, here we have this guy. That's the mode switch, playback recording switch. So depending on if you have recording enabled or not, so if you press the record button, then this switch activates and it switches the functionality of the amplifier quite drastically. It puts it into record mode. We can have a look at that in the on the schematic, but this one really needs to be clean because there is a lot of contacts. See, it has a lot of contacts and it's everywhere in the circuit. So if there are some contacts not making good connection, you will have an intermittent amplifier. And then we have a switch here in the AC socket. So if you plug in the AC cable over here, then this switch cuts off the battery power. And over here we also have a switch mounted here underneath. I don't know if you can see it. Let me just focus on that. Oops, that's the motor that fell out. See over there, this rectangular block which is mounted beneath the DIN socket, that's also a switch. And that cuts off the microphone, the internal microphone. So if you plug in something in the DIN socket, then this switch, then the tape recorder assumes that you connected an external microphone and it cuts out the internal microphone. So we're also going to check this one. Now the first one, arguably the most important one, is this guy, and I can already do that here right now. Just gonna spray some contact cleaner in there and hope it finds its way in there. Oh yeah, it will. Come on, is my can empty? No, almost empty. Right. So we're gonna clean this up. The first thing I'm gonna do now is clean all these switches. And then we can try to power the amp up and see if we get any sound. Because in the previous video, right in the beginning, before I started the restoration, I powered up the tape recorder and we didn't have any sound at all, not even a crackle in the speaker or anything. So it seemed to be totally dead, but it could be just as simply as a dirty switch. So let me clean all these 5 switches and then we can check and see if the amp is working. Right, so all switches have been cleaned. These guys here, so this switch here in the DIN socket, you can actually remove it. What you need to, I didn't show it on video because I don't think it was that interesting, but you can remove this cover plate here first, and then you can remove the entire socket, and then you have a bit better access to this switch beneath. So all the switches are cleaned. Let's see if we have sound or if we have a hum coming out of the speaker now. I've set this switch here to the playback position. That's the record position, because in the I suspect that we will hear something. If we will hear something, it's in the playback position. I connected the bench power supply positive over here. The negative is just chassis. I took it over there on the motor, and I set the power supply to 7.5 volt. And then we should hear something. Where is the switch for the PCB? Over here. So here I have dangling the power switch for the amplifier. If I close that one, we should hear something. So let me just turn on the power supply. It's turned on and it's not drawing any current, which is good because, well, both these switches are open. Let's see if we hear something. The volume, let's put it in the middle somewhere. Aha! I think I hear something. Yeah, indeed. I now have a hum in the speaker. and it's drawing 45 milliamp at the moment with the volume on 7 out of 10. So that's already looking quite a bit better than before. Okay, let me turn off the power supply. So we have sound, that's already important. Now, how can we test this without having the mechanism inside? Well, I can use the line in. I can show you on the schematic immediately, but this thing has a line in for connecting a radio, for example, so that you can record on tape. But it also plays the sound, if I'm correct, yes, it does. It's clearly visible on the schematic. It plays the sound to the speaker as well, so I should be able to connect the signal generator here to the line in, and then we should have some tone. Let me figure out how to do that, and let me explain you maybe also on the schematic how this works, because the schematic of this thing, it looks quite simple. It's not too big, but it's not that easy to understand. Once you start to look at it, it's more complicated than you would think because of this playback record switch, which is riddled everywhere in the schematic. So that switches lots of different things around when you switch that, flip that switch around. So the method of operation changes quite a bit between playback and record, and then you also have the thing that you can play back from the tape head or from the line in or from the microphone. So you have all these different combinations and all these different audio paths, which make things a bit, well, difficult to understand if you look at it at first. But let's start with the line in. Just to show you, I have now the signal generator here connected to the line in, or well, I call it the line in, but it's just the input here on the DIN socket. And I have a 1 kilohertz tone on there, a 1 volt RMS. And I just enabled the power supply again. And if I close here the switch for the amplifier, see, there we have the 1 kilohertz tone. Yeah, that's my cell phone causing interference. But see, it's working. It's working quite well. Yeah, the interference, let me just put my cell phone here in flight mode if I can. Okay, that's in flight mode. That's better. And it's quite clean. Actually, we have a bit of hum, but nothing too dramatic. It's rather okay. So let me show you on the schematic how this is working and which components in the circuit we are actually using with this test. So I think it's not a bad idea to have a quick look at the schematic more in detail. Now, if you don't like these kind of in-depth views of the electronics, then, well, you can always skip ahead. I will put chapter titles in the description, so you can skip ahead to the next more practical stuff. But I do like to explain a bit the schematic so that we have a better understanding on how this thing actually works. So this is simply from the service manual. And at first sight, it looks quite simple, like I said. There is not a lot going on. But as I already explained, there is this switch, the mode switch between record and play functionality, and this switch has quite a bit of contacts, 30 to be exact, and they are riddled all over the place. So this switch is S1, and for example, see, we have here S1 over there, over here, and there is this part of the switch, there is a part of the switch, There are more places, I'm sure here as well. So it's a bit everywhere. And the way that this circuit works depends on the position of that switch, and also the flow of the audio depends on the position of the switch. So the way it is drawn here is, see, here is one as well. It is drawn in the playback position. So all the contacts are with the switch in the position for play or start, stop, fast forward, backwards, whatever. If you press the record switch, then they flip around. So if you press the record button, that's the only case where all these contacts as one, they switch around to the other position. But let's have a look at the record functionality later. Let's first try to understand how this thing works in playback. So first of all, just to be complete and very quickly, here we have the power supply, and we have the mains socket and the battery. And then here this switch S5, that is the switch in the mains socket, and that is switched position when you plug in the power cord for the mains. If that is not plugged in, then simply this transformer and bridge rectifier are bypassed, and you have the 6.5 volts of the battery simply going here to the, let's call it B+ for the amplifier, and then here for the motor. This circuit is simply the power for the motor, and this is this motor control switch that switches the direction of the motor. In the normal position, this is S2, like it's drawn here. The motor is off, and then depending on if which you push start or fast forward, it goes in that direction. If you press rewind, these both contacts, they go in the right direction, and that controls the direction of the motor. We have one big capacitor here of 2200 microfarad, but that's it. So you see the motor control is very simple. It's not electronically controlled. And it does pose a couple of issues, because if your battery voltage goes low, when your batteries are draining, then the motor will start turning more slowly. Also, these days we have 240 volts on the mains, not 220 volts. So that means that the voltage coming out here of the bridge rectifier will be higher as expected, and the motor will run faster as expected. And we don't have a way to, calibrate this, because if you calibrate it for 7.5 volts, it will probably run too fast on the mains. We'll have to check later, and I still have to decide on how I'm going to set the speed. But just to show you here the specifications, they are quite relaxed with their specifications. See, where is it? See, so we have here tape speed 4.75 centimeters per second, plus or minus 2%. So they say that the tape speed can vary 2% fast or 2% slow. That is quite a lot for a cassette player. So, well, I guess they were not able to guarantee it better than that, because they have this very simple way to drive the motor. Anyhow, here we have then the 7.5 volts that feeds the amplifier, and this switch here, that is the leaf switch, the small leaf switch that I had to press to get the amplifier going. And you can see if that's open, then nothing on this page gets power except for the motor, if that switch is closed. See, so only when you close that switch you will power the rest of the circuit. Here we have the filter capacitor of 1000 microfarad and another one of 220. Then, so what I did is I fed in a signal via the line in, remember? And that is this socket over here. You can see that we have a DIN plug here, and that has basically two connections. So pin 1 and pin 4 are connected together, and pin 3 and pin 5 are connected together. The pin 1 and pin 4 is the microphone input, and the pin 3 and pin 5 is the line in and line out combined on one signal. So I fed it basically here into pin 3 or pin 5. So this side, this is where you feed in the signal from a line in. And I went on the computer and I highlighted the audio path in case I was using the line in. See, so we are feeding the audio signal in here from this DIN socket. It goes through this 8.2K resistor, through the switch, it's the record play switch, and then it makes this small loop to the volume control, and then we go here again to the play through the switch as one, and then we go here, end up in T4, that's the driver transistor. And then it's quite interesting, this amplifier. So we have on the output, we have 2 times and 2 SB495. That's a PNP germanium transistor, I believe, yeah. So we have 2 PNP transistors, and then we have here a transformer which acts as a phase splitter. So the signal comes in over here, goes into the primary of this transformer, and then you have 2 secondaries, and the outputs here on these 2 secondaries, they are wired up so that they are 180 degrees out of phase with each other. So for example, if you have a signal here that goes like this, then you hear it's the other way around, 180 degrees out of phase, and that feeds these both outputs, and then here on the midpoint you have a coupling capacitor, and that goes to the speaker. So with our previous test, what have we actually tested? We have tested the main amplifier section, so these 3 transistors. Now they seem to be working. I do get quite a bit of noise on there. I don't know if it is due to the germaniums that are getting leaky, or some coupling capacitors maybe. You see we have some capacitors here and there, some filter cans. Maybe these are also causing an issue. I don't know, but this is it. At least it's working, and also the transformer is good. That is a very important piece. If that was bad, it would have been maybe the end of the project. So you see, the part of the schematic that we tested is not really that big. So the first thing I am going to do here is change the capacitors here in the amplifier section, and also here in the filtering, even though probably they don't really do a lot because we are feeding in 7.5 volts from a power supply on the bench here. These filtering capacitors, they are mainly useful for the AC when operating this on the mains, but I'm going to swap them anyway. So this one, this one, this one, then here these coupling caps, this 0.47 microfarad, here is a 100 microfarad, here this coupling capacitor of 2200 microfarad. I think that's it for now. I'm just gonna start swapping these. Maybe I can also do the one on the motor here, just to be complete. So those I will swap, and then we can test this again. Well, I went ahead and changed all the capacitors in the amplifier. Then I tested the tape recorder, or the cassette recorder, sorry. And everything was still working fine, so I just went ahead and replaced all the remaining capacitors as well. That was quite a lot of work, because you see, typically these cassette decks or tape recorders, they are riddled with electrolytics. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 on this PCB, then 14, 15, 16. So yeah, I think 16 capacitors for such a small device. Took me quite a bit of time. Here you see I always mark the capacitors as I go when I change them out, which one I've changed, and the same thing here on the schematic. Now, interestingly, these two guys, now I don't know what they are. I think these are old tantalums. These are .1 microfarad or 100 nanofarad. And these are used as coupling capacitors in the preamp. I can show you here on the schematic where they are. So see, it's that guy and that guy, C4 and C5. Now, I tested these. Well, I tried to test these. I don't have really good equipment to test these small value capacitors. For example, this meter usually doesn't go long enough for 100 nanofarad. I think you need like at least 220 nanofarad to be able to test, to be able to use it. But when I pulled one, because I didn't know if they are good or bad, now I have mixed results in the past with old tantalums. They can go bad. So I pulled one and see, it says capacity not measured, but ESR more than 40 ohms. And that was suspicious to me, because normally these should say capacity too low or to measure. See if I take the other one. See, that one says open circuit / low capacitance. So that's what it should say. But the fact that this guy told me capacitance not measured and an ESR of more than 40, that's suspicious. And then I took my cheap Chinese tester. And there, if I put it in there, see, it says ESR of 66 ohms. Now this guy is obviously, it won't give an exact figure because it's a, well, not calibrated cheap thing. But the fact that it says 66 ohms, that's not great. 120 nanofarad, so the capacitance is still more or less okay. If I take the other guy, it will be probably the same thing. See, 86 ohms, 130 nanofarad. So I just swapped these out. I think they are not great anymore. So I swapped these with 100 nanofarad tantalums. I still had those laying around, so I popped those in. Then there is something else. I swapped one transistor. See, that's the one here in the amplifier, the preamp. Because it's a 2SC871. And this is a transistor which is commonly known to give issues, this type of transistor. I checked the other ones and they are not problematic, the types. So if you go on Audio Karma, there is a list of top 10 worst transistors of all time. That's the title of the post, but the goal of that post on Audio Karma was to make a list of problematic transistors. In the end, they ended up with much more types than top 10, but that's the type of the, well, that's the title of the thread that you can find it under. So if you just type Audio Karma top 10 worst transistors in Google, you'll find that post. And that one is on the list. It's a 2SC871, that guy. So whenever when I go through audio equipment, all these transistors that are on this list, I swap them out by default because they get all kinds of well, failure modes like noise or mainly noise or crackling, popping, all these kind of things. So especially here up front like that, when you really want to have a low noise transistor, it's not a great idea to have this transistor still in there. So I replaced it with a KSC 1845. That's a modern replacement. It's a much better transistor, so that should be perfectly fine. I think those are the only things I did so far. Well, I spoke also about taking out the speaker, but I'm not going to do that because it's glued in, see? And it would not be, yeah, anyway, I will not be able to clean beneath the speaker panel. There is dust underneath, so you have here the grill. Yeah, let me show you. See, you have the grill, and then you have a sort of plastic bezel. But that plastic bezel, that is melted in place. See, so you have plastic tabs and they are melted. So that's impossible to take out. And then it doesn't really make sense to take the speaker out as well. It's glued in place. I'm just gonna leave it. So I'm going to now start putting everything back together and then see if it still works. So I put everything back together. That was quite a puzzle. It took a bit of time to mount the motor, this PCB for the power supply, those two switches, and the main PCB back on here. That was quite a puzzle, but I think I managed to do it. Now I'm just replacing these two belts. This tiny one here, that's an annoying size. I now put a 20mm belt, folded length, so I always measure my belts folded length. So that means that the circumference is twice the amount. So I put a 20mm. I think that's a bit too tight, but the measure larger that I had in my stock was 30mm, and that's sorry, I put 25mm. Yes, I put 25. And the size larger that I have in my stock is 35mm. And that's definitely too large. This is very tight. See, it's maybe a bit too tight. I think the ideal size would be 30, but I don't have that in stock, so 25 will have to do. And now I'm replacing the main belt. Of course, I need to take the bracket off here, just to do that. Let me do that first. And I'm just... Something fell off. I think that's just a piece of old glue that fell off. So I don't have any exact measurements of these belts for this machine, so we'll have to go by trial and error to find the correct size. You can just put on a belt and see how it works, but if you want to have a starting estimate, then you can do it like this. You take a small piece of rope and you put it along the belt path like this. So this is how normally the belt should be. You pull it nice and tight. See? It's a bit fiddly. See, like that. Okay. And then you measure that length. Where is my ruler? So that is 24 centimeters. Yeah, 24 centimeters. So that would be a inner diameter or folded length of 12 centimeters. But you have to deduct a bit because obviously otherwise your belt will have slack. So most of the time you have to deduct like 10 to 15%. So let's start with a 10 centimeter belt. So I have here my belts of 1 square millimeter, and let's see what I can find. I have them sorted. Here I already have the 10 centimeter. See, I have them sorted by size. This is 100, so I think that should work. I think that's perfect. Yeah, it seems to be relatively okay in terms of tension. Oh, there is a bit of this washer that broke off. See, so that's probably the thing that fell. So I'm just gonna put that back. And then we should be good to go to continue the reassembly. Well, I think we're back in business. I have the chassis mounted back into the cabinet. Now I do have one washer left, one very tall, tiny washer left. I'm not even sure if it's from this machine. Don't know how that washer ended up in that box, but yeah. Anyway, I have the power supply hooked up again, 7.5 volts on the battery. And let's see. This is a stop. What is play? This is play, I think. This thing, which is very annoying to work on, does have an interlock, so you cannot push play when there is no cassette tape installed, so you need to push that down. Okay, that's working. I also have a hum in the speaker. That's good. Fast forward. Seems to be working. Rewind. Seems to be working. It's a bit jittery. I mean, it rumbles a bit. It's drawing 140 milliamp on the power supply. In play mode, it's drawing 90. But the capstan is working, the pinch roller, the take-up reel. Okay, let's put it in cassette. Yeah, it is not sitting in there. Without the case, it's not sitting in there correctly, I believe. Or am I doing something wrong? No, I think it needs the case to hold it in place. But let's try this already. Play. Okay. Ooh. That's very distorted. Wow, that's very distorted. What's going on here? Okay, the fast forward is working. The rewind is working. But whoa! That doesn't sound great. It's very distorted. Okay, look at this. I have a signal connected again to the line input, and I'm fiddling here with the record play switch. I'm not switching it to the different position. I'm just fiddling a bit with it. This is the different position. This is the record position. This is the playback position, but yeah, I think I'm actually not sure. Either this needs more cleaning, or this tab here, which operates the switch, is bent. I don't know. Right, well, I think I found the problem. Well, I'm quite sure I found the problem. I had a crack in the PCB. That took me a long time to find, and it was quite a frustrating experience because I couldn't see it at all. And when every time I put the PCB back in and when it screwed it down, I lost the connection. And sometimes when I pushed the PCB, then I had weird oscillations in the sound, and or the sound completely disappeared. So yeah, that was very weird. I checked all the solder points here, resoldered some wires, replaced the wire, didn't really change anything. And then after a while, when I was pushing it again, the crack became bigger. It cracked a bit further and then I could see it. Yeah, it was a really difficult one to spot, and it was over here. Wait, let me take this thing. So it's really started here at the edge of the board and it went to there. But you could really barely see it. So yeah, I think it was maybe it was my mistake. I don't know, but due to tightening this screw maybe a bit too much, that the PCB was cracked here. So I put a big blob of solder there. I repaired this trace because it split here, this trace and that one. And this one here is the ground. So this was creating like an intermittent ground, which obviously, well, yeah, that's quite clear that that's going to be the issue then. See, now if I activate here the amplifier, see we have a nicer tone going in. And no problem anymore whatsoever with intermittent behavior or weird distortion or anything. So yeah, that was frustrating. Now, I am going to put everything back together for the second time, and then we'll have to do the alignment if there is an alignment needed, or at least we can check the speed and the alignment of the head and all these things. So okay, so I got everything, well, everything. I got the chassis back into the cabinet. I've got a tape here. Now, I have to be a bit careful because since the cover here is not there, it's sitting quite loose. So I need to keep it a bit in place with my fingers. But it works. This is just an old tape that I use for testing purposes. There are some things that I recorded on there from the radio maybe 20 years ago. So let's see.
Spreekt. Een goede job zoeken is
See,
een goede
that's
Je vindt ze daar waar ze zitten.
Manpower. Good people. Good job.
that's actually working. And now, obviously, the audio quality is not going to be fantastic. It's not going to be hi-fi by any means. If you see how tiny the speaker is, and it's only mono, I guess. Yeah, it's a mono head. Yeah, it's a mono head. But this is really used for voice. Well, intended for voice. A tape recorder like this, not really for music. But
Voor onvergetelijke voetbalmomenten, rechtstreeks en exclusief, ga naar je Kanaal Plus verdeler of bel 02 716 53 53. Kanaal Plus, je beleeft het nergens anders. Dit weekend, de toppers Genk staan daar en Gent Club Brugge. Ja, uw voornaam?
Matthias, met de M van de G.
so it's actually working, and it seems like the speed, it sounds correct, it sounds stable. So well, we'll see. I'm just here gonna check the service manual, see if there are some adjustments mentioned. There should be, because it's a very good service manual. And then see what we can, or what we still need to do. Okay, so let's do the speed and wow and flutter first. I'm just gonna take my speed test tape here. And now, the manual states specifically that you shouldn't adjust the speed. See, so it says here tape speed adjustment, that even though there is a speed adjustment on the motor, if the speed is off, you should just replace the motor. And the thing is, the specifications that they give here are very relaxed and very conservative. So they say a tape speed of plus or minus 2%, and the wow and flutter of less than 35%. So that's well, I hope that we meet those specifications. They are very high, basically. So let's see, I have the test tape here. I have the wow and flutter meter connected directly to the speaker output, so you will hear the beep. I will turn down the volume as much as I can, so apologies for that. I'm just too lazy to take the line output. Okay, let's see. Yeah, I have the power supply turned off and not correctly connected, so let's try that again. And nothing is happening because my tape is not seated correctly. Okay, let me turn down the volume here. Yeah, you cannot see anything. Right, let me show you here on the meter. So we have a speed. I'm just gonna turn it down. Yeah, now it's gone. See, we are about 2% slow, a bit below 2%, let's say 1.5% slow. And the wow and flutter is, yeah, I'm poking the cable here. The wow and flutter, so that's, I'm using the upper scale, so that's 0.2%, that's 0.3%, that's 0.4%, so we are around between 0.3 and 0.35 somewhere. So, and I mean, the tape is just sitting loose, it's not held in place by the door. So that's more or less the spec. So I think I'm gonna leave it at that. Okay, azimuth alignment. I've got my azimuth test tape and I've got an AC voltmeter here connected to the line out, just like they prescribed in this service manual. And then I am going to adjust this screw here for a maximum. But let me see if I can get a setup here that you have a bit of a better view on the voltmeter itself as well. Well, there is no way that I'm going to be able to set this up so that you can see me adjusting and the voltmeter at the same time. So this will have to do. I also don't have a dual camera setup at the moment. Okay, so let me start the tape. And here let's... Okay, the tape just ran out. That's great. Let me flip it over. I just reached the end of the tape. Great. So there we have it again. And you see it's more or less stable. And let's see if we can adjust this for a maximum. Let me take another screwdriver because this one isn't working. Yeah, this one is working. That's clearly going down, other direction. Yeah, I think we were more or less peaked. Yeah, that's fine. Okay, so this might be visually a bit more interesting. The oscillator for the erase head. So they say here that the frequency of the oscillator should be 54 kilohertz, can be adjusted with the core of TR2, so there's a transformer. I'll show you on the schematic. Where is it? Over here. See, so here we have the oscillator. So this is the erase head. Let me focus, sorry for that. So you see here we have the erase head, and this is an oscillator, and this core can be adjusted, and that adjusts the frequency of the oscillator. And all this thing obviously is only active when recording, so we're gonna adjust this this core if needed. So it should be 54 kilohertz. And they also say that it's adjusted in the factory and it should not be adjusted afterwards, only if parts of the oscillator have been changed. But let's see. So I'm measuring here simply with the oscilloscope on the erase head. so between chassis and erase head, and let's push the record button, and there is nothing. Oh yeah, my power supply was disconnected. So we see a nice oscillator signal, and according to the scope it's 52.4 kilohertz. So let's try to get this to 54. And the core is located over here. And it's quite stuck. It's very stuck. Let me try with another screwdriver, and if that doesn't work, I'm going to leave it. Ah, yeah, it does work. 50, yeah, you cannot read that probably, but now it's 52.7, 52.8, 53. It's going up very slowly, and it's getting more difficult to turn, but okay, 53.5, 53.7, 53.98. That's okay. That's that step also done. Well, I've got everything back together. There is only one thing that we haven't tried yet, and that's the AC mains. So I have it hooked up onto the dim bulb limiter with an AC cable. Let's power that on. And let's see. Of course, I cannot do... I need to put in a cassette. Yeah, that's working. And it's playing better actually than when the case is closed, which is as expected.
En ik zal u meteen uitleggen waarom. Die jongen heeft 14 jaar, alleen maar getraind. Dat betekent niet zuipen, niet neuken en hij woont in Brabant. Nee, dat je deze.
Okay. Well, that door is not very enthusiastic. But hey, I guess that's the spring that's getting a bit old. But that's a bit comical. Okay. Well, I don't think I have to explain you that this thing doesn't really have the best frequency response, so musical reproduction is not going to be hi-fi by any means. So I put in some tape with some music, and it's acceptable. It's very muffled, well, muffled, I mean, it's acceptable. You have a small speaker, it's a very simple tape recorder. It has never really been made to play hi-fi music, it's mono, so we're not expecting too much. But it does go very loud. But it starts to distort quite quickly. But let's put some spoken word in there, because I think it's going to be better for that. I do have collected now some spoken word tapes. I've been going through thrift shops and looking for some spoken word tapes. And one of those... Wait, where did I put it? One of those is this. Boos. Well... Probably not really for the audience of my video, but when I was a kid, this thing was a popular TV show or a cartoon here in Belgium. I think it's Dutch originally. So this tape is from 1988, and this is basically from a kids show. So it tells a story and it plays some songs. So... yeah, there is a lot of kid-friendly voice acting on here in Dutch, obviously. So, this is the A side. Yeah, now I'm obviously in a song, which is annoying. And the fact that you have to hold this down to rewind is also annoying.
Je gaat me toch niet vragen of ik wil leren vliegen?
met die flaporen van me. Want dat heb ik al eens geprobeerd en dat geeft zo'n klap, als het ware.
Nee, Tum, dat doen we anders. Meneer Kraai, wakker worden. Ik wil u wat vragen.
Hey, hallo Dolly. Wat leuk dat je weer eens langskomt. Kan ik je ergens mee helpen?
Ja, jij was toch bezig met een kraaienfitnessclub?
Jazeker. We hebben alleen niet genoeg apparaten om mee te oefenen. Voor het gewicht heffen hebben we alleen maar eikenstammetjes.
So what I can do is I can take a direct output, because now you are hearing the very tiny speaker, which is not the greatest quality in itself, recorded indirectly through my microphone. So it probably won't sound great on the video. So what I can do is I can take a direct output of the tape recorder and record it directly on the computer, and then I can put it in the video.
Dat moeten we samen doen.
Dan moeten jullie alleen wel aan Tum vragen of jullie bij hem thuis mogen oefenen. Want dat ding is het dak van zijn huis.
Als jullie dat vlot voor mij nou in die bomen willen hammen, heb ik er geen enkel bezwaar tegen als jullie af en toe bij mij komen spotten, hoor. Oh, even voor alle duidelijkheid, hè. Is dit nou een vlot, een gewicht of een dak?
Ja, van alles wat, maar dat is nogal een lang verhaal.
Nou, laten we dan maar gaan hijsen. Goed, mannen? Ja! Mannen, luisteren. Jullie krijgen van mij allemaal uitgereikt 1 stuk schoenveter bruin. Wij bevestigen deze met een mastworp aan de buitenste stammen.
Well, there is actually one more thing that we haven't tested. Recording. Because it's a tape recorder, so it needs to record, right? So we're gonna just use the built-in microphone, because I guess that's what will be used most with these types of recorders. So let's see. I'm just gonna hit record, start. I have a tape here, again my test tape on a blank section, and let's see what happens. Okay, so this is the first test recording with the freshly repaired and restored ITT SL54 Automatic tape recorder. And I'm using the built-in microphone, and just to see if it is working and how good or bad that it sounds. Now, how far do I need to rewind this? Something like that. I don't hear a lot. That's not promising. Yeah, there is music. Well, that didn't work. Whoa. Okay, so this is the first test recording with the freshly repaired and restored ITT SL54 Automatic tape recorder. And I'm using the built-in microphone, and just to see if it is working and how good or bad that it sounds. Well, don't you love the background noise? Jeez, that's a lot of background noise. Now, I don't know where it's coming from. Is it from the tape recorder itself? The recording, my voice is sounding quite okay, but the background... With the freshly repaired and restored ITT SL54 Automatic tape recorder. And yeah, that not fantastic, but okay. Will I be able to plug in just like this an external microphone? Let's put it just a bit away from the tape recorder. All right, test number 3, now with an external microphone. It's the same vintage Philips microphone I used in the last video. So let's see if this generates a bit less noise. All right, test number 3, now with an external microphone. It's the same vintage Philips microphone I used in the last video. So let's see if this generates a bit less noise. Well, that actually sounds a lot better. Well, the sound itself is different. There is less highs in the tone, but that's, I guess, because this is such an old microphone. All right, test number 3, now with an external microphone. It's the same vintage Philips microphone. Okay, so that shows that if you're using a tape recorder like this, use an external microphone. It works a lot better. Okay, well, that's it for this video, I guess. The videos that I put out for this machine, they were a bit long. I hope you don't mind. But I really wanted to, well, keep this only in a couple of videos and not go into a series of 10 videos for this small tape recorder. I did enjoy repairing this one. There were a bit of frustrations, but hey, we managed to solve it and it's working pretty well. It's really vintage, and it's nice to have such a device in the home. It's not perfect, it will never win a beauty contest either. There are some scuffs, some scratches, but well, it's working perfectly, and I enjoyed working on this. I hope you enjoyed watching the videos, and I hope I'll see you in the next one. So take care, bye bye.